Hello and welcome to Who's Atom? Today we will be talking to scientists who contributed to the atomic theory. With me right now I have a famous scientist from 300 BC, Democritus.
Democritus. Hello there, I am Democritus.
So Democritus, tell me what sparked your interest in learning about these things called atoms?
Well, now that you mention it, when I was pondering and thinking and sitting, I discovered that things were made of something, but that something I could not know until I discovered these atoms, as you say. And then I realized that the atoms themselves remained unchanged. Everything and everyone was composed of them.
So you had this idea. What did you do then?
Well, when I decided that things were made of atoms, I figured that I must come up with a theory, you might say. This theory became the groundstone for every other idea known about atoms. People enlarged upon it and used it for their benefit, and thus created the atomic theory. Our next scientist is John Dalton. This guy. So, John Dalton, what were some of your ideas on atoms?
I found that all matters consist of tiny particles, and atoms are indestructible and unchangeable and microscopic.
Could you please elaborate on your theory?
Sure. I found that elements are characterized by the mass of their atoms. When elements react, their atoms combine in simple whole number ratios.
Ratios? Can you explain more?
Yes. 2 times oxygen plus carbon equals carbon dioxide. Therefore, each element is made up of atoms could only be in whole numbers.
Oh, I get it. Do you have an example of what you thought these atoms look like?
Yes, let me go fetch it. I thought that all atoms were solid spheres, such as this, and that everything was made up of solid spheres.
Were they microscopic?
They were.
And now we have J.J. Thompson visiting us. Welcome, J.J. What was your big idea that helps the progression of the atomic theory?
My big idea was the idea of the electron. I ventured inside the atom to discover something new.
J.J., how'd you figure this all out?
Well, I used a cathode ray. This cathode ray helped me come up with this idea that rays are made of particles smaller than atoms. I started reading inside the atom, and through this, discovered the electron.
J.J., how'd you prove your new theory?
I proved this by negating the belief of that an atom is homogeneous, and by discovering that inside the atom there are multiple parts. Through my experiments and through my hypothesis and conclusions and the data that I drew, people believed me.
J.J., do you have a model of your atom?
I do. I will get it. Oh, it's heavy.
Tell us about it.
This right here is called a raisin bun model or a plum pudding model. Through this, I discovered that it wasn't just a solid sphere. As you can see, there are things inside of it, or raisins, as you might say. These raisins were called electrons.
Our next guest is Ernest Rutherford. Ernest, you were a physicist. How did you become involved in the atomic theory?
Well, I ventured into chemistry.
And what did you discover?
I experimented with alpha rays and I put these alpha rays into a chamber. And when some of the rays didn't go straight through the chamber, and when some hit the sides of it, I realized that the atom couldn't have been completely homogeneous. I realized that there had to be something inside of the atom that was making these deflections occur. Thus, I came up with the nucleus.
The nucleus?
Yes, the power center, the powerhouse, if you will, of an atom.
Ah, and you also created a model of what you thought the atom looked
Yes, some call it the planetary model, some call it the nuclear model, in reference to the nucleus that I discovered.
like. What is this?
That is my diagram of what I discovered.
And what is this in the center?
That is the nucleus, the thing I discovered.
And surrounding it?
Those are electrons surrounding the nucleus.
So, our next guest is James Chadwick. So, James, what did you discover?
I proved the discovery of the subatomic particle known as the neutron.
What is a neutron?
The neutron is an elementary particle devoid of any electrical charge.
Great.
And next on our program, we have Niels Bohr. Welcome, Niels. Good to have you.
Glad to be here.
What did you do to help the atomic theory progression train?
Well, I discovered that isotopes of an atom are unstable. I also discovered that the nucleus contains protons and neutrons.
And that was building off of Rutherford's discovery of the nucleus, was it?
That was.
Wow,
His idea helped me a lot.
good. You made a very intricate model of your theory. This is your model, Niels, is it not?
It is my model.
Explain it for us, would you?
I would love to. The things on the outside are called electrons.
These here.
Those are, yes, very good. Those are electrons. In the middle, we have protons and neutrons. This model is still used today and is a lot more intricate and complex than that of my fellow scientist, Ernest Rutherford.
Very interesting. Thank you, Niels Bohr.
Next we have Louis de Broglie and Erwin Schrödinger. So, Erwin, you came up with an equation. What was it of?
My mathematical equation described the path of that electrons would most likely follow in their orbit around the nucleus inside the atom.
So, you two came up with a model, I hear?
Yes, it is called the electron cloud model, sometimes known as the quantum mechanical model.
And it looks like this.
Yes, it does.